The town where I live boasts of being the closest you can get to the geographic center of the nation. Another way to put that is to say that I live in the middle of nowhere, and as far as it is possible to live in the United States from any ocean. And yet the condition of the global ocean has a huge effect on my life. Let's understand how. We just talked a little bit ago about the heat that the ocean has absorbed and continues to absorb. When scientists talk about ocean temperatures, they're generally referring to the temperature at or near the surface. And there's some scary news about the global average sea surface temperature. This number has reached its highest ever by a lot over the summer of 2023. In early April, the global average sea surface temperature was 69.9 degrees Fahrenheit, which is a little over 2 degrees warmer than the long-term average temperature for that date. Take a look at this figure. This plots the daily sea surface temperature for every single day since 1981. The fine dotted line in the middle is the average for each day of the year from 1982 through 2011, which you could consider a long-term average. That heavy line at the top, that's 2023. Way off the charts. The oceans are hotter right now than they have ever been. I'm sure you've seen the news about hot tub-like temperature around the coast of Florida. 2023 also saw marine heat waves in the North Atlantic, the Caribbean, the Mediterranean, and several other parts of the global ocean. But so why should I care about a slightly warm ocean? What does that have to do with me? The most immediate way in which ocean temperatures affect me is by driving our continental weather patterns. The temperature, pressure, and moisture of the air masses moving across the continent determine our weather, and all of those factors are hugely affected by the condition of the ocean surface. Air masses move across the ocean onto land, loaded with energy and moisture absorbed from the ocean. In general, warmer water evaporates more readily than colder water, so more water vapor goes into the air. This can mean that more moisture is available to fuel precipitation over land. But these processes are complex. Of course, just as land surface temperatures are not the same everywhere, the sea surface temperature is variable as well. And the locations of masses of unusually warm or unusually cold water make all the difference. That's what El Niño and La Niña are about. You hear those terms in discussions of weather, and they're confusing. There's a more detailed explanation for you in connections, but the short version is this. The name El Niño refers to a situation where there's an area of unusually warm surface water concentrated in the tropical Pacific Ocean off the coast of Peru. In a La Niña event, that same area is colder than normal. El Niño and La Niña together are called the El Niño Southern Oscillation, or ENSO. These are patterns that have operated for a long time. They were first described by sailors in the 1600s. Oddly enough, there are reasons why everyone in the world is interested in the surface water temperatures in that one specific area. The Peruvian coast sounds far away from us, but the temperature of the ocean in that location has a big effect on us. Just look at the different weather patterns that develop across the United States when these two events occur. Here's the general pattern for winter weather during an El Niño pattern. As you can see, that's very different from a La Niña winter. Of course, these impacts aren't limited to the United States. For example, El Niño conditions tend to bring hot, dry conditions to southern Australia, which can fan the flames of bushfires. La Niña, on the other hand, can cause severe droughts leading to fires, food insecurity, and ecological havoc on the other side of the Indian Ocean in eastern Africa. Right now, we're in a transition period between a rare 3-year run of La Niña conditions into what is shaping up to be a strong El Niño. So we can expect some changes to our weather patterns. Now, if you throw in the overall rise in global temperatures due to climate change, you get, well, weather chaos. And that's a really important thing to note. It's true that average temperatures are rising, but an even clearer trend is that extreme heat is intensifying, as are other types of weather extremes. But speaking of extreme ocean heat, another pretty in-your-face effect of hotter weather, like what we've got on Earth right now, is the intense storms that occur in the ocean itself. Depending on where you are in the world, they could be called cyclones or typhoons, but we call them hurricanes. And hurricanes, of course, can be devastating. Of the 10 most costly natural disasters in U.S. history, 8 were hurricanes. The damage caused by a hurricane can be from several factors. The strong gusty winds alone can break or uproot trees and power lines, tear roofs off buildings, and cause general havoc. These winds also bring heavy rain, which can cause extreme flooding. But perhaps even more awe-inspiring is the storm surge. This is a photo from NOAA of the damage from the storm surge from Hurricane Ike in 2008. Storm surge is when the sea level is raised above the normal tidal level by the low pressure of the storm. Together with the waves whipped up by the cyclone's winds, this can produce a wall of water that slams into the coast during a hurricane, like a tsunami. Of course, the increase in water level is on top of an already increased sea level due to the background effects of climate change. The important thing to understand is that the energy that powers hurricanes comes directly from the heat energy in the water. The warmer the water, the more energy available for the storm. This awesome photo from NOAA is of a hurricane eye wall. Interestingly, it's not yet clear if the number of hurricanes happening each year is on the rise. What is startlingly clear is that once a hurricane gets started, they're becoming more intense more quickly as water temperatures increase. This has led to extremely damaging storms here in the US as well as around the world. A tragic recent example of this is the explosive intensification of Hurricane Otis, which gave the people of Acapulco no time to prepare, and many lives and much property was lost.